Lesson 2-2, Adding Integers. The objectives today in this lesson are to add two integers, and the other objective is to add more than two integers. Before we start, let's introduce two key terms: opposites, two numbers with the same absolute value but different signs, and additive inverses, an integer and its opposite. These two key terms are basically the same. They basically mean a pair of numbers that add to be zero. If you look at the key concept, additive inverse property, here in the example down here at the bottom, you can clearly see that 6 plus its opposite, negative 6, is equal to 0. Such numbers as negative 0.3 and 0.3 when added will give 0. Even fractions work. Negative half and a half being added together give you 0. So those are examples of opposites or additive inverses. In the first objective, adding two integers, we're going to talk about integers with the same sign. In the key concepts here, you can see some examples of negative 5 plus negative 2 is equal to negative 7, and 6 plus 3 is equal to 9. The thing to remember here is a three-step rule here with same signs for integers. We're going to find the absolute value of each number. Absolute value was in 2-1. Then we're going to add them. Then we're going to put the sign of the greater absolute value on the result. So if you can remember these three steps, it'll help you adding integers with the same sign. Before we begin with the key concept of adding with absolute values, let's go back to a method. It's the number line. We'll use negative 2 plus negative 3 on the number line to find the answer. You can see that we have a number line here, and we're starting here at negative 2. So I'll place a little corresponding dot at negative 2. What is happening is that the plus sign tells us to move to the right. Pluses always mean to the right, but the negative in front of the 3 is telling us to switch directions. Instead of going to the right, we're going to go to the left, and we're going to go 3 spaces. 1, 2, 3. You can see we ended up at negative 5. So the answer to this is negative 5. And that's using a number line, just something that you might have been taught in the past, and some students like to use it. Alright, let's get back to the example of using absolute values. We're going to use the problem negative 4 plus negative 5. Notice that there is addition, and the signs of the two numbers are both the same. They are both negative. So first thing I'm going to look for is the absolute value of negative 4, and that's the distance away from 0. So negative 4 is 4 spots away. And I'm going to do the same for negative 5, and negative 5 is 5 spots away from 0. And then after I do that, according to the steps, is I'm going to add the 2. And that is 9. And then I look, and I notice that 5 is the largest absolute value, and the sign is negative. So I'm going to add negative to my result. And there's your answer. As with adding integers with the same sign, we have adding integers with different signs. As you can see in the key concept, we have some examples of integers with opposite signs. 7 plus negative 2 is equal to 5, and negative 7 plus 2 is equal to negative 5. We have the same set of rules almost for different signs. The first step is again to find the absolute value of each number, but instead of adding, we're going to subtract them. And remember, we're going to put the big absolute value minus the small absolute value. After we've done the subtraction, we're going to put the sign of the greatest absolute value on the result. Let's do a couple of problems. Before we begin with the absolute value solutions, let's go back to the number line. Let's use this problem, 7 plus negative 4, and the number line. You can see that we have addition, and the signs are different. 7 is positive and 4 is negative. We'll start with the 7. That's where we're going to start out here, so I'll place a dot there. So we begin at 7. The addition sign says move to the right, but once again, the negative inside the parentheses tells us to move to the left, and the number 4 tells us to move left 4 spaces. So I'm going to move to the left 1, 2, 3, 4. We end up at 3. So our answer here is a positive 3. Now that we've finished with the number line, let's return to the method using absolute values. In this problem, I notice that we have addition, 2 plus negative 3. Since the signs are different, I am going to go ahead and find the absolute value of the numbers, 2, and the absolute value of negative 3 is 3. So I'm going to take this and set it into a subtraction problem, because that is the second step, is to subtract. I'm going to take the larger number and subtract with the smaller number. The result here is 1. I'm not done yet. I'm now to look at the two numbers. The one with the largest absolute value is the sign that I want. In this case, the largest absolute value is 3, and the sign for 3 was negative. So my result will be a negative 1. Here's another problem that says find the sum. I look at the problem, it's addition, and the signs are different. So according to the steps, the first step is to find the absolute value of each number. Negative 8 is 8, and 3 is 3. Since the signs are different, I am going to subtract. I'll take the larger number, then the smaller number, find the result. 8 minus 3 is 5. Before I can say 5 is the answer, I'm going to look and see which one is the largest absolute value, and that is 8, and the sign of 8 was negative, so my result will be a negative 5. Here's another problem. Find each sum. 10 plus negative 4. It's an addition problem. The signs are different, so the steps ask me to find the absolute value again. So absolute value of 10 is 10, and the absolute value of negative 4 is 4. Then, since the signs are different, I'm going to subtract. Take the larger number, subtract it, 4. The answer is 6. Before I finish up, I look and I notice that 10 is the larger of my two numbers, and its sign was positive, so my answer stays a positive 6. In this slide we have a word problem. It's astronomy. During the night, the average temperature on the moon is a negative 140 degrees Celsius. By noon, the average temperature has risen 252 degrees Celsius. What is the average temperature on the moon at noon? Reading the problem, I notice that the question being asked is, what is the temperature at noon? Since that is my unknown, I'm going to define my variable n as equaling the temperature at noon. I'm going to use that in my equation. I know that the temperature starts at a negative 140, and then it rises 252, and rise to me means add. And the question was, what is the temperature at noon? And there's my variable n, which is defined as temperature at noon. I'm going to go ahead and do the work. I found the absolute value of my two numbers. 252 is 252, and negative 140 is 140. Since the signs are different and I'm adding, I'm going to use subtraction. And when I subtract, I get 112. Before I can call that my answer, I look to see my original numbers. My largest number had a positive in front of it. That was the 252. That means my answer will be a positive 112. And since it's a word problem, 112 is degrees Celsius. In this slide, we are on our second objective, which is to add more than two integers. In problem A, we have 9 plus negative 3 plus negative 9. I am going to start off looking for integers with the same sign. I notice negative 3 and negative 9 are the same, so I'm going to work with those first. This is what we would call associative or commutative property, where we're grouping like terms together, or like signs together. And so I have a negative 3, and I'm going to find the negative 3 absolute value is 3, and the absolute value of negative 9 is 9. Since the signs are the same, I'm going to go ahead and add. 9 plus 3 is 12. Now I'm going to remember that I'm going to take the sign of the largest absolute value, which was a negative 9. So this 12 becomes a negative. I'm going to bring down the 9 and the addition sign in front of it. Now I'm back down to two numbers. I notice that there's still addition, but the signs are different. I'm going to find the absolute value of 9, which is 9. The absolute value of negative 12 is 12. Since the signs are different, I am going to take the larger of the two numbers and put that first. And with the signs being different, that means I'm going to subtract. So that means I'll have 9 minus 12. That gives me the answer of 3. which I'm not done yet, because I'm going to look back here and I notice that my largest number was negative, which was 12. So my result will not be a 3, but it will be a negative 3. We have another example of adding more than two integers. Once again, I am going to use the commutative and associative property to move the problem around to make it easier to work with. First thing I'm going to do is take the negative 4 and the negative 3 and group them together. So I have a negative 4 plus a negative 3. Then I'm going to go ahead and take the two positive numbers and group them together, a plus 6 and a plus 9. Now I can work on these two numbers individually here. Since negative 4 and negative 3 are the same, I'm going to find the absolute value. I'm going to add them. That is 7. The sign of the largest absolute value is negative, so the answer here is going to be negative 7. Notice that 6 and 9 are both the same. I'm going to go ahead and find that I can add them. 6 and 9 gives me 15, and since they're both positive, go ahead and add those. Now we have two numbers, negative 7 plus 15. The signs are different, but we're adding. So once again, I'm going to take the absolute value of 7, the absolute value of 15. And the signs being different means that I'm going to subtract, taking the large number first, smaller number second. The result of that is 8. Now I need to go back and look at my last step. I notice that 15 is the larger of the absolute values, and the sign in front of it was positive, so 8 will remain positive.